Hello everyone and welcome to this video presentation of the course I teach at the University of Biskra titled Biostatistics. In this video we will go over the content of the course and what you can expect to learn. This course has 5 main chapters. The first chapter covers descriptive statistics of one dimension. The second chapter is about 2 dimensions. Chapter 3 introduces the basics of probability theory. Chapter 4 is about hypothesis testing. Finally, Chapter 5 covers analysis of variance or ANOVA. Together, these chapters provide a solid foundation in biostatistics for application in health and biological sciences. So, what is biostatistics? Biostatistics is the application of statistical methods to biological and health sciences. It helps in designing studies, analyzing data, and drawing valid conclusions in medical and veterinary research. This model equips students with essential tools for data interpretation and evidence-based decision making. Now, let's go to the first chapter, which is about descriptive statistics of one dimension. So, what are the objectives of this chapter? At the end of this chapter, the student will be able to identify different types of data, qualitative and quantitative, describe the difference between measures of central tendency and measures of dispersion, compute measures of central tendency, mean, median, and mode for a given dataset, construct frequency tables and histograms. Chapter 1 contains first types of data. So data can be divided into 2 main types, qualitative and quantitative. So qualitative describe qualities or categories, for example, blood type and gender. Quantitative represent measurable quantities, for example, weight, age, and temperature. Second, measures of central tendency and dispersion. So central tendency shows where the center of the data lies. The mean is the average, median is the middle value, the mode is the most frequent value. Dispersion tells us how spread out the data is. The range is the difference between the largest and the smallest value. The variance and standard deviation show how much the data varies from the mean. Third, how to compute central tendency. Let's say we have the ages of 5 animals, 2, 4, 4, 6, and 9. So the mean equals to 2 plus 4 plus 4 plus 6 plus 9 all over 5 and equal to 5. The median is the middle value and it is 4. The mode is the most frequent value and it equal to 4. Fourth, frequency tables and histograms. So frequency table organizes data by showing how often each value appears, useful to quickly identify patterns in large data sets. Histogram is a type of a bar chart for quantitative data. Each bar represents a range of values, called class intervals. Now let's go to chapter 2, which is about descriptive statistics of 2 dimensions. So what are the objectives of this chapter? At the end of this chapter, you will be able to define key terms such as bivariate data, covariance, correlation coefficient, and contingency table. Calculate covariance and correlation coefficient for a given dataset. Compare the strength of association between different pairs of variables using correlation values, and construct the regression line. So chapter 2 contains first key terms. First we have bivariate data, which is data with 2 variables, for example age and weight of animals. Next is covariance, which measures how two variables change together. So, if both variables tend to increase or decrease together, the covariance is positive. If one increases while the other decreases, the covariance is negative. We also use the correlation coefficient, often written as R, which measures the strength and direction of the linear relationship between two variables. The value of R ranges from -1 to +1. Lastly, we have the contingency table. The contingency table used for qualitative data to show frequency combinations of two variables. Let's now look at covariance and the correlation coefficient. Let's say we measure the age and blood pressure of 5 animals. So covariance gives the direction of relationship, positive or negative, as we explained before. The correlation coefficient tells us how strong that relationship is. For example, if R equals to 0.9 means strong positive correlation, and if R equals to -0.3 means weak negative correlation. So the closer to +1 or -1, the stronger the relationship. A value near 0 suggests little to no linear correlation. Now, let's talk about how to compare the strength between two variables using the correlation coefficient R. For example, if we find that R equals to 0.8 between age and weight, and R equals to 0.2 between age and height, so we conclude that the age and weight have a stronger association. Finally, let's talk about the regression line, which shows the best linear relationship between two variables. The equation of the line is y equals to a plus bx. In this formula, y is the dependent variable, for example weight, x is the independent variable like age, b is the slope, which tells us how much y changes from each 1 unit increase in x, and a is the intercept or the value of y when x equals to 0. This line allows us to make predictions and understand how one variable affects another in a clear visual way. That's a quick review of the two main chapters. So, chapter 1 is about how to summarize and visualize one variable, and chapter 2 is about how to understand relationships between two variables. So, we end the video by a conclusion. So, biostatistics is essential for understanding and analyzing biological data accurately. It supports evidence-based decision making in research, medicine, and public health. Mastering its concepts helps students interpret data, detect patterns, and draw meaningful scientific conclusions. We have reached the end of the video. I hope that the video was useful to you, and I hope that the information I provided was valuable to you. Thank you for your attention, and see you soon in the next one.